Hello, long time no talk. Last video I made, I showed you this. I had you vote on when we were gonna meet and such, and then I never responded, and the reason was basically I knew that we weren't going to be able to meet because my wife's grandma down in California died, so she is actually down there this whole week. And so I'm at home with Barrett, so there was no way I was going to be able to go to Warden, and I knew that last week, like on the 23rd or 24th, so probably should have posted a video telling you that there would be no new videos, but yeah, I didn't do that, sorry. iPad was in my backpack upstairs, and I never really thought about it. Hopefully none of you were like just anxiously checking YouTube every day so you can learn. Maybe someone was. But let's see, it's Wednesday now. Got a few days left. Might as well get a couple videos in before we get back. I'll do like one today, maybe one or two tomorrow. I won't post anything new after Friday, so if it ain't up there by Friday morning, there's not going to be anything new over the weekend. So we'll just got to do a little bit though. Well, there's still a few days left. So here we go. This one's all about implicit differentiation. It's a little weird. So up until this point, we've done derivatives of all kinds of functions, right? If we could do the derivative of y equals x squared, any power with using the power rule. We can do derivatives of square roots. We haven't done derivatives of absolute value functions, but that's just more thinking than anything. Let's see, what other kinds of functions have we looked at? Anything with a fraction, we know the quotient rule. What other kind of functions? Oh, trig functions. We've done derivatives of trig functions. I can't remember. Is there more? Thinking. Anyway, we've done derivatives of all kinds of functions, but what we haven't done derivatives yet is non-functions. And by non-functions, I mean something like a circle. We can do the derivative of that. For example, if I said here's a circle, find the slope at the point. So find the slope at, we'll say, what's my point? 3, -4. You can imagine what that looks like. Hopefully you kind of remember a little something about circles. This one, the center would be at 0, 0. Remember the formula? Let's go. The formula for a circle was like x minus h squared plus y minus k squared equals radius squared. That was left and right shift. That's up and down shift, and then the radius. So just x squared plus y squared would mean your center is at 0, 0. And then, since we have 25 over here, we'd have a radius of 5. So we'd have a circle. So the slope at the point 3, -4 would be, what's the slope right here? So we could find the tangent line at that point, we can find the normal line, all if we know how to do the derivative of this. So to do that, I'm going to back up. This is just kind of a weird notation thing. So going back to just our regular x squared, when we do the derivative of that, a lot of times we would write y prime equals 2x, and that would be your answer, right? Well, there was also a different way of writing it, which would be dy dx equals 2x. And we're going to be using this a lot in this section, this dy dx idea. So here we go. I'll do an example, give you some steps, do a couple more examples. So to do this, we're not going to solve for y, because if we did that over here, by the way, this side, you don't really need to write this stuff. This is just like me talking. So if we do that, x squared plus y squared, because if we subtracted x squared from both sides, we'd have y squared equals -20, 25 minus x squared. And then you'd have to square root it. So you'd have plus or minus the square root of this. So then we could do the derivative of that, but then we got to do it like, there's like two different things here. There's one that's positive and one that's negative, and that sucks. So we'd have like this to the 1/2, and then chain rule it. A lot of work. It's a real pain in the ass. We're not going to do that. So what you do is what's called implicit differentiation. Don't get hung up on the name. Implicit versus explicit. Not going to get into a lot of details here. Just going to get into nuts and bolts of how you do it so that you could pull it off when you see it. First step, and I will write these steps down after this one. You differentiate both sides with respect to x. Basically meaning you take the derivative of both sides. So I just write, I'm going to do the derivative of this side, and I'm going to do the derivative of this side. Okay, now you just go through, and since this is just a polynomial, basically, I don't know. It's just two things. You just do the derivative of each one of those. So we go through and we do this. The derivative of x squared is 2x. This is where it gets kind of weird. The derivative of y squared with respect to x, I'll just tell you how to do it, not really why. You do the derivative of that thing just like you normally would using your power rule. So the derivative of y squared is 2y, but then you also have to write times the derivative of y with respect to x. Anytime you're doing these and you're doing a derivative with respect to x and you come across a y, you still do it the same way, but you just have to write dy dx next to it. For example, let's say I just had a big old string of crap here, like x to the third plus 2y to the third plus 4x squared minus 6y plus 7 equals 0. And let's say I was trying to do that one, and I'm doing the derivative with respect to x on both sides. Well, who cares about that side? That's just 0. So you go through and you would do, on all the x's, you just do like regular. So like x to the third would just be 3x squared. But anytime you do a derivative of something that contains a y, you do it. So you go 3 times 2 is 6y squared, but then you have to also include dy dx. Moving on, plus 8x, and then here you'd have derivative of negative 6y would be minus 6 dy dx, right? Because it's just a y. So it's just going to go to negative 6. I mean, basically you do that, we could have been doing that the whole time. Anytime we had anything like y equals 3x to the 4th plus 7x, we could go, derivative of both sides. Well, the derivative of y is just 1 times dy dx. And this side would be 12x to the third plus 7. Well, 1 times that. I mean, we've really been doing it all along, just not writing it. It's just a notation thing. Alright, so there we did the derivative of that. We did the derivative of that one. Going over to the other side, derivative of 25 is just 0. Next step is you get everything with dy dx, all the terms that have that piece in it, to one side. So in this case, there's our term. That's our only term that has that, so that's just going to stay there, and I'm going to move this 2x over to the other side by subtracting 2x. That's 0, so now I have 2y dy dx equals negative 2x. Now I solve for dy dx, which in this case I just need to divide by 2y. So, because this is all multiplication, divide by 2y. So now derivative of y with respect to x equals, here I got negative 2 over 2, that's just 1. So I have negative x over y. So there's my derivative of that. And you're going to have y in your answer. Sometimes you might only have a y in your answer. It just, I don't know, it depends on the function. So back to the original question of find the slope at 3, -4. Well, here's our equation for our slope, our derivative. So we just plug in 3 for x and -4 for y. So basically, oops, I was going to write f prime, but we're not going to do that. So you'd have -3 over -4, which would be 3/4. And that makes sense. It should be a positive slope right there, right? So that's it. That's implicit differentiation. That's all you need to know. Kind of. Here are the steps. I told you to write them down. First thing you do is differentiate. That means take the derivative. Differentiate both sides with respect to x. And that's what we did here, where we just did the d over dx thing. Then you get everything. You get every term that has the dy dx to one side. So get them all on the same side. So that's what we did here. We just got it to the same side. Third step we didn't have to do in this problem, but sometimes you'll have to factor out dy dx. We didn't have to do that here because after we got it to the one side, there was only one term that had the dy dx, so we just had to do step 4, which is solve for dy dx. We'll do another example right now that has number 3. See, I should probably do a simple one. Okay. This is actually an example in the book. It's 3. Just work through it here. I'll do this one and then one more, because this one's kind of weird. This one's crazy. It says, show that the slope dy dx, that means slope, so that's kind of redundant. Show that the slope is defined at every point on the graph, and it gives you that weird function. So it says, show that the slope is defined at every point. So what you're going to do, the way you're going to go about that is, you think about slope, you know, well, it would be nice to know the equation for the slope, or the equation of the derivative. Because if you knew that, then maybe somehow you could show that no matter what numbers we plug into that, we'll get an answer. So that's what that would mean. You know, the slope is defined. The only way we wouldn't get an answer is if we have the square root of a negative, or we're dividing by a 0. So let's see what happens here. So basically we know, here's our, I don't want to say function, here's our equation. So we're going to do the derivative of that and go from there. So you don't have to move anything to begin with. You just start with your steps. Step 1, differentiate both sides with respect to x. So, I mean, I'm not going to rewrite it here. I'll just dy over dx of this side and that side. So going through here, the derivative of 2y, well, you just do the derivative. Derivative of 2y is 2. But then since there was a y, you have to have dy dx equals, over here, derivative of x squared is 2x. Derivative of the sine of y. Well, the derivative of sine is cosine, so you'd have the cosine of y. Since there was a y in it, I have to add the dy dx. And this is all multiplication. It's like cosine of y times dy dx. I know you get confused if I just write a big string of things all next to each other. So there's our first step. Second step, get everything with dy dx to one side. I like to move it to the left, just personal preference. So that's already over there. So this has a dy dx in it. This is all multiplication, so they all have to stay together. So I'm going to bring that over. So I'm going to subtract the cosine of y times dy dx from both sides. Blah, 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 blah. So now I have this. I have 2 dy dx minus cosine this whole thing. Alright, I was lazy, didn't write it. Cos of y times dy dx equal, and I still have this 2x over here. Okay, now third step, this is where you have to factor out dy dx. Because now, at this point, you got everything that had a dy dx to one side, so everything on this side will have a dy dx. So since they all have that in common, we can factor it out. So I factor out dy dx. What's left? Well, factor that out of there, I'll have 2 minus, factor it out of there, the cosine of y. Alright, hopefully you remember how to factor, simple factoring of something out. Now solve for dy dx. Well, now it's easy because this is just multiplication, so I just divide by whatever's here. After you factor that out, you're just going to divide by whatever's there. So I'll divide by 2 minus the cos of y. That's dy dx equals 2x. Whoops, off the screen. And there's my derivative. Okay, now so to answer the question, said, what did it say? Show that the slope is defined at every point. Well, here's my equation for slope. So how can we show that no matter what I plug in for x and y, I'll get an answer? And the way, you can't really show it, you just have to explain it. You have to think, well, what would be something that, or how would I get undefined for my answer? And the way you'd have that is if you got 0 on the bottom, right? So if this was a 2, if the cosine of y was 2, you'd have 2 minus 2 on bottom, we'd have 0 on bottom, and be undefined, right? Well, can the cosine of y, or whatever I plug in there, if I do the cosine of anything, will I ever get 2 as my result? Thinking back to our unit circle days, you should know that no matter what number I plug in for y, isn't the maximum value for cosine 1 and the minimum value for cosine's -1? So I'll never get a 2. So that's what you'd say. No matter what I plug in here, the cosine, the value of this piece right here will never be 2, so this will always be defined. I will always get an answer. So yeah. One more example. Just a straight, this is actually number 1 from the problems in the book. I don't know, I just looked at it and it looked tricky, so I thought I should do it. Okay, so like I said, this is number 1 from the problems. So x squared y plus xy squared equals 6. Directions, just find the derivative of that. Reason I chose this one, like I said, it's a little tricky, and I'm going to assign you number 2 to do on your own. So this side is not tricky, it's just straight up. But this side, you might think, oh, 18xy, derivative of that is just 1. Well, no. So like right here, you might think, oh, when I do my derivative with respect to x on both sides, the common error would just be to go derivative of that is 2x, and the derivative of y is 1, so I just have 2x. That's a mistake. And the reason is we have multiplication here of variables, and we're doing the derivative of both, so we have to do product rule. You're going to have to do product rule here also on this 18xy. My suggestion to you would be to think of it as, I mean, it's all multiplication, so it doesn't matter, but I would group it as 18x multiplied by y. Just make it easier on you. So here, okay, product rule. Well, to do product rule, I gotta, so right now I'm just focusing on that x squared times y. We'll get to this stuff later. So I do, remember, product rule is just uv prime plus vu prime, or derivative of the first times the second plus derivative of the second times the first. So here we go, I got that. Well, derivative of x squared is 2x. Sorry, I'm thinking. Anyway, okay, so, sorry. Derivative of the first is 2x. Hopefully you carried on without me. I was watching Barrett on the monitor. I got a little TV screen with him sleeping. But, derivative of the first, 2x, times the second one, so that's just 2x times y. Plus, we're still on this one, right? So we got the derivative of that one times that one. Now we got to do the derivative of this times this. So the derivative of y in this case is just 1, but since it's a y, we got to have dy dx times x squared. Should clean this up a little bit. This is just multiplication, so we can just write 2xy. And we got 1 times that times x squared. So I like to write dy dx in the back always. So this would just be x squared dy dx. And that just looks a little better than whatever I did there. So that's the derivative of that piece. Well, now we got this one. So we're going to have plus. So I'm going to ignore that for now. So now here we go. Same thing, product rule. Derivative of the first times the second. Or I might have done it backwards before. I don't know. Doesn't remember, product rule doesn't matter what order you do it in. So derivative of x is just 1 times the second one, so it's y squared, plus, now I'll do the derivative of the second one. So the derivative of 2y, or derivative of y squared, is 2y dy dx times the first times x. So here it is again. Product rule. Derivative of the first times the second piece plus the derivative of the second times their first. Cleaning that up, 1 times y squared is just y squared. And then, like I said, I like to write it. This is all multiplication. I like to write that in back. So 2yx, let's write it 2xy, just looks better. dy dx. Equals, well, the derivative of that side is just 0. So now we got that big old thing. Doesn't look like there's any like terms to combine. It's not surprising. Step 2 is get everything with dy dx to one side. Well, it's already all on one side, so we're done with step 2. Oh wait, no, but good thing this came up. Sure, these are already all on one side, but you want them by themselves on that side. So we don't want this other crap here hanging out. Because right now we can't factor out dy dx because these two don't have them. So step 2, I guess, should say more than just get everything with dy dx to one side. It should say get everything to one side with dy dx and dy dx only. I don't know. It's hard to talk. I haven't tried to teach in a long time. So anyway, we got to get rid of this other crap. So we'll minus 2xy and we'll minus y squared from both sides. That's gone, that's gone. So what do we have left? X squared dy dx plus 2xy dy dx equals negative 2xy minus y squared. Now we can factor out dy dx from those because they both have them. So I got x squared plus 2xy equals negative 2xy minus y squared, and now divide by that. So your answer equals, remember it's negative 2xy minus y squared divided by that thing is what we divided by, x squared plus 2xy. You can't cancel anything because you got addition and subtraction. So I think the book, I looked, and the way they wrote their answer, this is perfectly good and acceptable. This top one is both negative. For some reason they factored the negative out, put it out front, and then wrote these as positive. So they put like y squared plus 2xy, and then, so no, not going to pick on anybody, but there's a particular person that likes to cancel these. Don't do that. There's an addition sign there. Don't, no. This, or this, whatever. Probably just stick with that. Okay, so here's some problems to try. I'm not sure how this is going to work as far as, I guess basically you show up on Monday with all of this done, even though I'm probably going to go over them all in another video. You'll get full points. So try those out. You'll have answers for 3, 9, 13, and 17. So 2 and 6 are the only ones you won't know the answers to. So here, we'll play a game here. For 2 and 6, a little incentive. First person to answer those correctly, let's see, what should you get? You should get some bonus points of some kind. I don't know, we'll barter. Let's get a conversation going in the comments here. First person to get, one or both of those right, you'll get some bonus points of some type. So comment with your answers to number 2 and 6. If you get it right, I'll ask you, what do you think you should get? Like, I'm thinking just like a free 10 on a homework. Like, I'll go back in your old homeworks. If you missed an assignment, we'll just add 10 points to your homework score. So, it's not much, but just kind of make it a game. Make it like you're going to win something. So if you only get one of the 2 right, hell, we'll get 10 points each. So 10 points for that one, 10 points for that one. If you get them both, you get 20. Whatever. I don't know. I'll be sure to check the comment. Oh, I gotta go. Perfect timing.